Hey guys, Bukoid here. I'll give you a video. I was going to give you guys one last night, but there was a lot going on, and I wanted to save some of it just to show you guys today and like really get into this. But we are now officially under a geomagnetic storm. Right now it's minor. I got you guys over here at Space Weather. I'll leave a link to this website, but you guys can get there by going to planetxnews.org, and the links that I go to are all there on that page. So this is on there also. So if you guys want resources, it's a great resource there. Go there, click on whatever you guys want to look at, and so on and so forth. Now, right there it says it's a minor storm, right? Well, right here is the wind speed. Okay, 533 kilometers per second. All right, just a minute ago before this updated, it was actually probably, even if you went back and watched the beginning of this video, I think it was saying like 6 something. So when this one says that kind of a high number, we're getting pelted with winds. Okay, this one just seems to be a little bit more on the lower side when it talks about its winds. Now, see, look at there. It's already doing it. Updated again already. Look, 591. So yeah, this thing is they're updating that pretty quick. Oh shoot, there it goes again. Okay. Anyway, obviously, okay, here's the KP level. Again, just think of that like a thunderstorm warning system. You know how sometimes they'll issue thunderstorm watches and it goes to a warning, then it'll go to tornado watch and warning, and so on and so forth. That's kind of what this is. This is just a KP index. It takes data and it computes it into some sort of a level or an index. Obviously, it's this KP index, but it gives us some sort of idea of how strong the magnetic activity is. Okay, so it takes information from the satellites and it puts it into this, and this is where they generate that number from. Okay, now I've talked about this before. When these winds started increasing, like I said yesterday, it got up to a 4, and I'm not sure if you remember me saying this or not, and I may not have even said it, but I kind of called it a disruption or what have you, just increased activity, because it got up to a 4. Now, when it gets to a 5, they consider that a G1 storm. Okay, now it's a low-level storm, guys. I mean, it's nothing huge. But the difference with this one, and I'll show you here in a minute, is that the winds that are hitting us is actually, compressing our shields out in front enough that it's getting inside our satellite orbits. When it does that, that's some pretty good pelting. Okay, why is a G1 level storm doing that to us? Well, the only thing I can say is I think it has a lot to do with our shields weakening. Sometimes a low level storm like this will do that to us, but this is a continued thing now. If you guys look here, when it went up to this level, it kind of came back down a little bit, and it came down here, kind of leveled out, and then all of a sudden, boom. Okay, now that's typical. We see that a lot with these storms. But I think this is going to continue. I really do. If not, get stronger. Okay. I'm not sure if it will. I don't know that any of us really could say, hey, yeah, that's going to get strong. Because when we're looking at a coronal hole, which increases our winds, our solar wind speed, you can't really tell the strength or the speed of that wind until it actually gets the data from the satellite. So, yeah. I'm sure there's some more technicalities there that maybe, people that are way smarter than me can maybe take a stab at how something strong is by looking at a coronal hole. But, I can't do that. So, I have to trust these numbers that they're giving us. I do believe that this is true. I don't think that this is something that is being altered in any way. Because they're not. I haven't seen anything crazy with the Magnetosphere tools at all. I haven't seen anything. Matter of fact, I haven't even seen, sometimes when they go into safe mode, they'll kick off for like a half hour and come back on. I really haven't even seen that. And that's odd because I see that quite often on a day when we're not even having any kind of issues. Now, when we're under storm conditions like this, they may increase the energy that it takes to put these satellites into safe mode so they can still get readings. I'm not sure if they do that or not. I don't know what their guidelines are for that, but this right here is a good indicator that the satellites are getting hit with energy. Okay, that's not supposed to look like that. That is definitely a malfunction of the tool. Okay, it's getting hit with all these solar winds and this increased energy. All right, this is looking at the sun from our perspective. I believe this is X-ray. Is that what that is? Yep, X-ray imager. Okay. That big line going across typically ain't there. It is. You guys can pretty much tell that's just a faulty image right there. They're having issues with that. Now, here's another way to look at the KP. Okay. This one does it just slightly different. You can see the yellow there. That's at a 4 though on this one, and then the 5 they changed it to red on this particular graph. I don't know why this is different than the other, but it's just what they've used on this particular tool. And it says right over here, it says the KP. Okay, it's the same thing. It's just they're showing it to you in a different graph. Now these are line graphs, and you guys, you can go look at these if you want. The electron flux, that's kind of, and the proton flux, those are all good things to look at when those get increased and decreased. It does give us clues to what's going on. I'm not going to go into that right now because that's actually a pretty deep subject. But this part here is kind of neat. If anybody doesn't know anything about this particular website here, Space Weather, this one right here it's an Aurora forecast. Northern Lights, Aurora Borealis. And Southern Lights, I would imagine they're Southern Lights too, but I'm not sure what they call those things. But yeah, so what it does is you push play and it'll give you let's see if it'll do it. If it does it pretty quick, we'll just run through it and watch it. It'll tell you to kind of forecast what they think the auroras are going to be like. And what do I mean by that? You see how they're moving right there? See how they're increasing? So basically what they're saying, when you see that, you can pretty much tell that the ions are getting increased because it's bouncing off of our atmosphere, and that's what creates all this stuff. Okay? So when they start getting down to like mid-latitudes or longitudes, sorry about that. When it starts getting, I'll just put it to you this way. When it starts creeping down towards the equator, okay? When it starts coming down from the north, the lights will come down to, it gets right there in the northern part of United States. Okay, sometimes they'll creep down into here. Okay, I've even seen them as far down as here. Okay, so that isn't something that's abnormal, guys. It's just something neat to look at, and it's really cool. Now you see that right there. So when you see that big round circle there on the top where it's predicting all those auroras, that the energy is definitely increased and it's bouncing off of our atmosphere and it's creating those lights. So, but anyway, let's go on over here. I'm going to run you through some stuff here real quick. I'm going to take you over to my gallery real quick, because I want to show you guys some stuff. Okay, like I said, I was going to do this last night and I just didn't. I wanted to wait because there was so much stuff going on. Now, this is the side I just took you to, okay? Again, there's that, and there's that, right? Now, this is what I want to talk about, okay? This is the sun, right? And this is a capture from yesterday. Well, actually, it's today, which would have been 2 o'clock in the morning UTC, okay? Which is would have been 10 o'clock Eastern time. But that's when this capture was taken. Now, you see what I've outlined here, right? Why did I outline like that? Well, these are dark areas, guys. Okay? What I'm saying is, I think, and I haven't really looked yet, and we'll go look here in a second, matter of fact. But, you know, here's that coronal hole that's giving us the winds that we're getting right now. Okay? This is a very open, dark area. Okay? I think there's already a coronal hole about right there, and there may have even been one like right here. We'll go look at the SDO here in a second. But, and then, you know, here's that sunspot that gave us those two small X flares. Very, very small, by the way. They weren't much of anything, but they did happen. So, but if this coronal hole, if it, you know, materializes into a true coronal hole and it becomes, you know, completely open like this one was, yeah, we're going to see some winds for an extended period of time, guys. All right, so that's why I'm bringing this up. Now, earthquakes. Guys, when we're under these kind of conditions, especially given what's been going on lately anyway, the earthquake risk has got to be high. Okay? Volcanoes also. Just any of that stuff that's involved there, okay? But please keep this in mind. We'll go look at this SDO real quick here in a second. But I want to show you guys something real kind of interesting. Okay? This is that graph I show you guys a lot. This is the one that, this is the solar wind speed. And this is the density up here, right? Now, that's pretty self-explanatory. Like I've explained that quite a bit. But what I want you guys to pay attention to is the date. Okay, because they update these things daily. Now, remember what I said, that this is predictive and it's historic. Okay, what do I mean by that? I've been asked that question quite a bit, actually. Well, what I mean by that is that it will show you the past 2 days, and then it'll try to predict what the conditions will be for the next 5. Okay, but they update this every day. So why is this important? Well, if you look right here, okay, on the 25th, this is back in June, okay, they were predicting the density to go up, the solar wind to go down, okay, and this was on the 25th, all right, so I snapped this one, I think it was on the, when did I get this one? 6/26, this is when I took this capture. You can tell that by, oops, let's just, it's down here, bottom right corner, okay, so, then I took this one. Obviously, it was like a day or two later. You see how the graphs have changed? All right, that's very interesting because they're trying to predict stuff and their predictions are off. Okay, obviously they can't tell if a CME is going to happen or an X-flare. Nobody can really say, hey, this is going to happen 3 days in advance. We don't know that. We don't get that kind of a warning, okay? So they have to, you know, modify these models every day. But what I'm trying to say here is if you go here, this was on the 7th, okay? Actually, I snapped this one on like the 2nd, I think, 2nd or 3rd. But you can see how these models are differentiated, right? Okay, so this is the one that, did I take this one today? No, this is yesterday, I think. Or the day before. When I snapped this one. But yeah, you can see, okay, now what we're seeing, this right here is what we're getting right now. Okay, so they successfully, I have to say, they successfully predicted our winds to go up. And they were basing it off that coronal hole I showed you. But check this out. Okay, this is the most updated one. This is today. I just took this one. Okay, now what's interesting is today's the 9th, right? It's right here. So you draw a line straight on the 9th. Okay, we're going into the 10th. And just like it's supposed to do, which it's doing now, when the plasma density goes down, the winds go up, right? But check this out. Look what they're predicting for the next, the 10th, 11th, 12th, 13th. And then the wind speed starts dropping back down. So we're looking at 4 days, according to even them, of high wind speed, above average wind speed. And if it gets up to this higher end, that's 550. I just showed you one that was at 600 from the same website. Okay, and I'll compute that into miles per hour here in a second. But okay, here's that, like I said before, here's that coronal hole that causes the winds that we're having right now. So, with that being said, that graph I just showed you, is this thing going to open up? Is this why they're predicting winds for the next 3 or 4 days? So what we're going to do is we're going to go over here and we're going to look at SDO real quick. Okay? And I'll just take you to the short version of it here. Let's see here. Yeah, let's just do this. This is the SDO, guys. You can go here. There's a link. I'll leave a link to this. What you do is you pick your angstrom, which is, see where it says 171 gold right here. Okay. I like the purple one. I tend to be able to see things more. Sometimes I'll look at the other angstroms also. I do look at all of them actually. But I tend to catch more on the purple one. For some reason my eye is able to see that better. Some of you guys might understand that also. Might agree. A lot of people like the teal view. But the 211 angstrom is the one I usually go to first. So all you got to do is you set your date. Okay. And what we're going to do, because I'm just wanting a still shot of what it looks like right now. But we'll look at a little time lapse here. So we'll start it at 0-100 on the 9th. And we'll end it at 23. Well, no, let's go. I want the most latest and greatest. Okay, so we got to go to the next day because of UTC time. Okay, but there we go. Okay, so it's going to give us 24-hour time lapse here. And then you just hit submit. Okay. And this is what it brings to you. Alright, now, yeah. I mean, look at that. Wow. Okay. What I'm talking about, I'm going to pause it. Okay. This right here is the latest capture. This is what it looks like right now. So, any winds that we're getting, any winds that would come from this would be 3 to 4 days from right now. That's why they're predicting those winds to stay up. Okay? And this is pretty much confirming what I'm saying. And again, this is the first time I looked at this today. You can see, if you just outline this, you see the darker areas, right? Okay, it's very similar in color to this dark area, which is a confirmed coronal hole. The darker areas down in here are definitely holes. Okay, I will say that. Now, what I'm talking about is that, you see how this is kind of hazy up in here? That's not a hole. That's just part of the sun's atmosphere. Okay, so Scott gave a really great analogy. He said, that's like its atmosphere. When a coronal hole opens up, it's as if somebody's peeling it back. Okay. That's really a great way to say it. So, that's what creates a coronal hole, and that, opens up that wind stream, and yeah, that's why we get these conditions. All right. And again, I do think that this is probably why they're predicting those winds to stay up. Okay. Because look how large that is. It's going to stay in, that dark area. If it stays, it's going to stay right here with us for a couple days. All right. The leading edge started last night, and then go to the trailing edge here, and who's to say that some more might even open up, or it might close up. Maybe we'll get lucky and it'll close up. You never know. But for the most part, history would tell us that this is what's going on. And what I'm going to do to give you guys some sort of a different view here, so you guys understand what I'm saying. I'm going to take you to the other angstrom, because you won't be able to see the hole very well on this other angstrom. This is why we look at all the angstroms, okay? And I'm showing you this for that reason and that reason only, so you can understand why we show you different colored ones, because there's times when we see stuff on one that we can't see on the other. Okay? So, you see this? Pick out a coronal hole on that. you won't be able to do it, guys. There's nothing there. Right now, I'm also looking at something here I just seen. I don't know if this actually happened. I'll have to go over to Seeds and check it out. I'm going to pause it right here. What am I talking about? Look at this right here. I do believe that was probably some sort of a little CME. If not like some sort of a release anyway, a filament release maybe. Let's see. Let's go ahead and play it, and we'll zoom into that. I know this is kind of sidetracking us right here, but that's okay. This is what we do, right? So see how that reached out and see how it went off. Now I can't say for sure if that actually let go or not. If that filament if the sun didn't let go of that filament, that's not a CME. Okay, it means the energy stayed. The gravitation from the sun was able to keep it there. Okay, it didn't get ejected out. Now, like I said, how do we tell the difference? Well, we have to go look at the other models. Okay, and a good way to look, and I'll just show you real quick, is if you guys are looking for filament releases and like looking to see if it's a true CME, the best one to look at after you think there might be one is the 304 angstrom. Okay, and I'm going to show you why. Because if you see it on this one, it almost confirms that, hey, there was something going on there. Okay, because of the way that this one shows you. Okay, as you can tell, you don't get to see as much haze. Okay, it's more defined. It is more precise, I guess you could say. Now, if you look on the sides here where we were looking, is right in here. Now, you're seeing it dance around a little bit. Okay, and we would watch this and see what it does. And I don't know that it released. Okay, it may not have. Sometimes you just see a little flash, and that's a release. Okay, that's all it takes. Those things you're seeing dancing around there, those are filaments. Okay, like a filament in a light bulb, but it's in a really, really large scale. Okay, and so when the sun lets go of one of those, that's pretty much what we would consider a CME. All right, coronal mass ejection. It's not a solar flare. It's just, it's actual the coronal mass getting ejected out. Now, just because we don't see something on this one doesn't mean something wasn't going on. Okay, but anyway, I don't want to keep this video real long. But I am going to take you guys over here and show you what the Magnetopause is looking like right now. You guys will, yeah. Those of you guys that haven't seen these really before during storm conditions, this is definitely nothing to fear. Okay, guys? I want to say that straight up. Because when you see these, you're going to think something's really, really wrong. But it is being affected very, very strongly by something that probably, our shields, like I said, are weaker now. So it doesn't take much to actually affect us. Now, see, this right here is just, I don't like this. Remember what I said about it being in satellite orbit? Or inside the satellite orbit? Oh, man, look at that. Okay, so what we'll do, I'm just going to go ahead and run these through here real quick. Now, I'm also going to explain something, too. You're going to hear terms like geosynchronous orbit, okay? What that means is that there's that orbit, okay? And I'll go into it more detail. This is just a little quick definition. But the satellite itself is orbiting the Earth at the same speed that the Earth is rotating. Okay, the Earth spins. That's its rotation. The satellite's actually going around the Earth at the same speed as the Earth is rotating. So when that happens, when it's in geosynchronous orbit, which is what that's called, it means that it basically, if you go outside and you look up and there's a satellite right above you and it's in geosynchronous orbit, it will stay there with you all the time. It will never move from that position as far as your perspective. Okay? It's moving in space, but it's moving at the same speed that we're rotating. Okay, it's kind of like how the moon does, then that's why we only get to see the front side of it. We don't get to see the dark side of it because it is orbiting at that exact speed that it needs to, which is amazing to begin with. But yeah, I'm just going to pause that. I'm going to get this other one loading while we're going to watch that one. You're going to see some really crazy stuff here, guys. It's going to look very, very intense, and to be honest with you, it is intense. It's not, like I said, Carrington event type of stuff, but it's not going to take an event like that to affect us. It's not going to take much to give us an event of that size, is what I'm saying, as much as it used to. Okay, just because our shields are weaker. And why is it weaker? Because the sun is in a minimum, okay? So when the sun's strong, typically we are too. Our shields are. And I said this before, the sun actually protects us from the sun. Because if we get weak and then the sun has a big flare, we're not able to fight that off as well. And it will affect us more. So okay, now we'll go over here to this one. Now, I'm going to take you guys back all the way. Okay, I'm going to run through this with you real quick, and you're probably going to see a whole bunch of crazy looking signatures. Okay, for those of you guys that don't know, the sun's over here. We're getting energy this way. Okay, now all of this energy may not be coming directly from the sun. Obviously, we've been talking about, like, back on the 3rd and the 4th when we were getting hit and we didn't know where it was coming from because there were no coronal holes, at least that were facing us at that time. So this energy was coming from somewhere else, and it seemed to be coming from south of the sun. So, take that for what it's worth. Obviously, there were other magnets or magnetic fields in play there. And that's the only, if it's not coming from the sun, it has to come from somewhere, guys. And magnetically, that's really about the only explanation we got. It's got to come from some other source. So we're being influenced, and we were talking about the 28-day orbit, and and that's not just the only magnet out there, guys. I mean, it's lots more objects. Okay, look at that. Watch this. You see that? Watch. Move back. Look at that. Wow. Look. Okay, what does that look like to you guys? I want you guys to seriously think about that for a second. Doesn't that look like we have a bow shock on the backside? Okay, I'm not saying we do. I'm just saying that's because we see that kind of a signature out in the front all the time. I'm just saying. Now, geosynchronous orbit. Okay, when we say that, we're talking about this. See this dotted line? The satellites are in that orbit right there. So when we say that it's getting broke down, that means that the energy is getting inside of that, which it is back here. And when we get compressed, and I'll show you here a couple captures, it's actually doing it in the front also. Okay. See how far in that energy is getting close to, I mean, it's really inside of that satellite line. Wow. Okay, there we get hit right there. See how we compressed? Now watch. See how we bounce out? It's called rapid expansion. Look at that. Okay, massive compression. Boom. And we're expanding out. Well, now what I find interesting is that we actually expanded out towards the back a little bit that time also. Wow, look at this energy. Man. Now, look at this, okay? This is why we're talking about earthquakes, okay? Look at this egg shape, guys. That means that we're getting pressure from both sides. We're getting squeezed, okay? Now, everybody freaks out when we start getting hit with pressure like that, right? Well, what a lot of people don't talk about is the rapid expansion, okay? And I'm going to explain something to you here real quick. I was talking to my friend Mike today, and we were actually talking about this a little bit. you know, I've been praying for Mike. Mike's a good guy, and he's had some stuff going on, and, you know, everybody needs prayers. But here we go. Look. Okay, when we get hit like that, right? And then we expand. Okay? Now, the expansion, you see how we push out further than what we typically were? Okay? It's not normal. We're actually pushing out further than what we are during normal conditions. We get hit. Okay, I'll back it up till we get hit right there. Okay? Probably the one before that even. Yeah, see how close that is to the geosynchronous orbit there of the satellites? Okay? Now, we get hit right there. Then we do rapid expansion. Okay, picture this in your mind. Say you had, I don't know how to say this. Let's say something was being held in place on a ball. Okay? And you squeeze that ball. Okay, the stuff that's on the surface of that's going to move a little bit, right? But when you let go and there's more pressure on the inside, it pushes back out, right? Well, the stuff that's on the surface as it's pushing out is getting affected too, as it's pushing out further than what it was. So basically what I'm saying is, if the Earth's pushing out like that, it's letting go of some pressure. And sometimes that pressure is actually helping us stay stable as far as movement with, you know, earthquakes and a number of other things, you know, tides, all of it. Okay, so during this rapid expansion, we see a lot of things happen during this sometimes. Okay, it can be just as dangerous, if not more, than the initial hit. Okay, the rapid expansion part of it is actually concerning sometimes. A lot of the time. Okay? And also keep in mind that, you know, sometimes it takes days for this energy to really go back the other direction. In other words, sometimes the Earth, the mantle will absorb some of this energy, and then we'll see earthquakes after that. So, you know, there's a whole lot to take in here. And I've never, in my entire time of doing this, seen a signature like that. I don't even know what to say about that one. Wow. It's almost like it's feeding something in right here. And there's a break that I don't know what to think about this one, guys. You know? Leave me some suggestions down in the comments there. I don't know what that, I mean, that's really, really odd. I've never seen one like that, guys. I'm not saying it ain't never happened, but... And see the green color here starting to get closer and closer to the Earth now? I mean, inside that orbit. Look at this. Wow. Okay, look at this. Watch. Oh my gosh, that's one of the best examples I've ever seen of that. I want you guys to watch something here, okay? And please follow with me here, because this is important. You see our shield out here? Okay, see the blue and the yellow and the green there? See how it's all staying intact? Now, I want you guys to watch what this thing does. Okay, now there's a double bow there because of different waves are hitting us, right? Now, you see how it's starting to open up right there? This is something we typically wouldn't see. And what you're going to notice here, and I've noticed this the past couple times, is when you start seeing this, it actually will follow through down to here. You see how that's open? Basically, what I'm saying is, guys, I think that we're getting opened up to a certain amount of energy than what we typically would not have been in the past because our shields are weaker. Now look at this. See that? That's completely open. Wow. And again, guys, I have not seen a signature like this ever. Again, look. All the pressure down here is wide open here. That's even real dark. I mean, it's just like a straight line. If something was to come and hit us, we're expanding right here, guys. Okay, this is part of that rapid expansion. Okay, see how we're still pushing out? Now look at that signature. Tell me that that is not a break in our shield. Okay, I mean, does that not look like a break in the shield right there? Now, does it break all the way down to our surface or into our atmosphere? That I don't know. Because this is really kind of the shield line, our bow echo, whatever you want to call it. You know, is stuff making it past that? Is it stuff making it to the surface? Are we seeing outages and stuff like that? We've seen a few outages, guys. Is it being caused by this? I don't know. I guarantee you, I bet there's communication disruptions. Look at that. Okay, now, you know, if I just seen this part and none of this was up here, that really wouldn't even be a big deal. But because these are both here, that means in my mind they should be connected, and they're not. Something has kept that like that. Okay? Now, let's see here. Wow, man. This is pretty crazy. Wow, I just don't even... I mean, look at that. Whoa. Man. There's triple echo there, by the way. Okay, we'll keep going forward. Now, you're seeing that? Now, look. See how it all went back? And then look at that. Severe compression again on all sides. I bet we bounce back. Yep, there we go. Okay. Fighting back. Got compressed again. Boom. Back out. Wow. Look at this. Okay. Oh, wow. Whoo. That's some pressure on the backside there, guys. Man. Okay. Enough of that. Okay, I'll just show you the other graphs here real quick. You're going to see waves, right? I mean, we're not going to spend too much time here. I mean, you can see these waves. Boom. And I've been showing these day after day, guys. And I think this is going to continue, like I said, guys, because of that one coronal hole. I think there's another coronal hole opening up that's going to be Earth-facing. I do. Either that or it's at least a voided area that, you know, needs watched. Okay, here's the one, the IMF lines and the closed field lines and the polar lines. Look at that. Wow. Whoa. I mean, guys, these are some decent sized hits. Wow. Ooh, look at that. Okay, now that's interesting. Look. Okay, there ain't a whole lot going on up here right this second, right? Watch back here. Watch this thing. Watch our magnetopause. Watch what it does. That's even interesting too. You're going to see IMF lines right here in the middle. And they're going to kind of open up like this. Wow. That's really interesting. Let me zoom in a little bit so you guys can see that a little better. See how we kind of pushed out from the middle? Watch. Look at that. Wow. Crazy. Look at that. Whoa. And again, guys, I've seen... Oh, wow. Whoo. That had to be one of the bigger hits there. That was at 9... Okay, 2,100 hours, almost 22. Okay. Yeah, look at those, man. That was a big one. Wow. Okay, well, what we're going to do, I'm going to take you guys over here to, I'm going to show you guys something, that, and this is a very good visual. This is something that Scott turned me on to. Okay, this is the Magnetosphere models from over at planetxnews.org. This is one of the sites he uses. Okay, these are one of the links. Now, look at that. I'm going to show you guys the difference in the Magnetosphere models. Okay. First off, when you guys see this, the sun's on the other side. So the sun's actually off to the left. Oh my gosh, I have never seen a velocity one. That's the wind speed. Okay. We're going to hit play and we're going to watch it just for, well, excuse my language, but shits and giggles. Okay, I mean, go to these models, guys. These gives you a different perspective. Okay, it gives you a different visual. Look at that. Okay, now the really dark burgundy is really high winds, guys. Okay, It says 600, so that's like 600 kps or kilometers per second. All right. Now, obviously, you're seeing wave after wave come in, and what it does is, guys, it does a time lapse here. And the only bad thing about this particular model, I don't know how to get to if there is any history, any archived stuff of this. We could look at the density here, I guess, but the one I really want to show you is the pressure model. Well, that's loading pretty fast, so we'll watch it for a second. Okay, this is like I said, this is the density. So remember what I said, when solar wind speed goes up, density typically goes down, but that's not what's happening right now. They're both going up at the same time, which is why we're getting a hard hit. And again, I don't know that this would be such a hard hit if our shields were as strong as they should be on a normal basis, okay? Now look, see the pressure around the Earth here, guys? This model actually says pressure, okay? They're calling it pressure. A lot of the other models don't call it that. They can't remember what they call it, but they use different verbiage there. But see, watch this. You're going to see how we're reacting, and we're doing little waves of this and waves of that. Now, I took a little time lapse, and I posted it over on the Facebook group, Planet X News group over on Facebook. I posted that little small video of that. I think Scott posted one that happened like 3 hours before that. But I do want to show you guys that video. Let's see if I can't get to there. Here it is. Okay, watch this. This thing is, look, watch. Boom. See that? Ain't that crazy? That's some crazy stuff to me, man. Boom. It's the same one. I just like played it twice. Went back in the... So yeah, that gives you an idea of what's going on. Now notice the backside pressure. Again, you guys got to keep in mind the sun's off to the left on this one. Okay. Hoping that didn't kill my video here. Let's make sure. Nope, still going. Okay, cool. But yeah, guys. I don't really have a whole much more to say right now. I'll try to keep you guys updated on all this, but we are having let's go look at space weather one more time to see if they have updated and see where we're at as far as storm level. I was going to show you guys what that stuff computed to in miles per hour, and I'll probably, put that in my title here too, how fast the wind speeds are going. Again, yeah. Everybody's going to this right now because something is... We got stuff happening, See? I mean, yeah. So, we spiked up to a 5 on the KP index and then went back down to a 4. Only time will tell what's going on here, okay? But yeah. Well, let's just check out seeds real quick. See if it... Remember I said I thought I might have seen like a small CME off to the right side of the sun. Let's see if that... Well, I seen something there. Might not have been nothing, but... It could have been. Let's see. If it wasn't much. What I'm talking about, if you look down here, you kind of see it. A little bit of energy come off of the sun down through there. The SDO was showing a little bit of something there, but not a whole lot there to talk about. So, but yeah, guys, earthquakes, guys, please. Anybody in earthquake zones? They even put out a warning for the New Madrid, like a watch for earthquakes on the New Madrid fault line, which runs through the middle of the country, guys. Okay, this isn't out west. This is they're talking like a bigger quake could possibly happen there. I haven't had a chance to watch anybody else's videos yet today, guys. So if I'm repeating somebody else's info, I apologize. But just haven't had time to sit down and watch this stuff yet. And I really wanted to bring this bring an update to you guys and give you guys at least some sort of an idea of what we're doing, where we're at right now as far as all this goes. So, but I do think that right there is the reason that they are predicting the velocity, the wind speed, to stay up for 4 or 5 days in a row. Okay, that's probably what's generating that. I'm just gonna say that. I mean, that's the only thing I can see. Now, if I'm wrong, somebody please, correct me there. But I really think that's why they're predicting those winds to stay up, because they weren't doing that before. I showed you those models. Okay. I mean, they just weren't. They weren't showing any of that increase. Okay. But yeah, geomagnetic storm, guys. We're under a G1 right now. It's just minor. And again, watch out for earthquakes, guys. God bless. Yeshua saves, and you can drink this Kool-Aid.